Hello everyone, I am Mrs. Padmashri from SNS College of Engineering. Today I am here to explain the topic review of linear algebra for machine learning. So let's move on to the slide and explore what is linear algebra. What is the connection for linear algebra with the machine learning? So machine learning is full of probability and statistics concepts in which we are going to use the linear algebra for building almost all the machine learning algorithms. So let's move on to the topic. What is a linear algebra? It is a linear algebra is a branch of mathematics that is widely used throughout the science and engineering field. And linear algebra, it is a form of continuous rather than discrete mathematics. Many computer scientists have little experience with it. So, linear algebra is a mathematics concept which is mainly used to build the machine learning algorithm, and it mainly supports the continuous values rather than the discrete values. Linear algebra is a study of vector spaces, lines, and planes, and the mapping that are used for linear transformation. This is mainly used for linear regression. So, linear regression is a simple linear regression and multiple linear regression. We have two classification. When we predict the element with only a single independent variable, then it is a simple linear. The same when you are going to predict the element with more than one independent variable is said to be the multiple linear regression. So mainly the linear algebra helps for linear transformation. It was initially formed in 1800s to find the unknowns in linear equation. So we can say it is a young field of study. Linear algebra is essential in the field of mathematics. So linear algebra is an important part of application for our machine learning also. So mainly the processing, all the processing of machine learning algorithm is based on the concept of linear algebra. The reason for learning linear algebra. What is the reason behind that? In order to have the better understanding of linear equations and linear function, and linear algebra will help you to understand the linear programming, which is mainly useful for a machine learning model. To build the machine learning model, we use this linear programming. So, and also it helps to analyze the graphs visualization using the various parameters for diverse machine learning algorithm. We construct a better supervised and unsupervised algorithm with the help of this linear algebra. And what are the algorithms that is used that uses the linear algebra? So we have a supervised algorithm, logistic linear decision tree and support vector machine, and unsupervised algorithm as single value decomposition, clustering and component analysis. So some of the parameters that we should learn in the scalars in the linear algebra, such as scalars, vectors, matrices and tensors. This we all already we know the same concept is there in the linear algebra. Scalars is a we have only magnitude is a scalar, and the vectors we can say both the magnitude and directions is a vector. Matrices, we have 2D array of numbers. Often we represent rows, columns as features. And tensor, it is a generalization of both scalars, vectors and matrices in high dimensional representation. So matrix operations, we all know matrices will be having the addition, subtraction and multiplication. Now we have a dot product of rows and columns for matrix multiplication. For example, if A belongs to R to the power of m into n, and b belongs to r to the power of n into p, then we can write by combining these two equations, we can write A and B matrices belongs to r to the power m into p. And we all know that the matrix multiplication has transpose, inverse and identity matrix. Vectors and matrix form. The vector and matrix form, it has three thing. One is it mainly useful for measuring the size or length, and there are two types of normalization. As we all know, in machine learning we are going to normalize. What is the concept of normalization? All the outputs of the machine learning algorithm has to be normalized. uh, which means there are two types. One is the L1 normalization and the other one is L2 normalization. And the formula for L1 normalization, so we have summation of modulus xi, and L2 normalization has a Euclidean distance. It is the distance between 2 points. Say for example, if we have the point x1 and x2, the Euclidean distance can be calculated by using x1 minus x2 the whole square plus y1 minus y2 the whole squared. This is vectors and matrix. Dot product and cross product. It measures dot product measures the similarity between vectors. Cross product measures a vector which is perpendicular to both. And eigenvalue and eigenvectors, we have the formula for that, eigenvalue and eigenvectors. And we have principal component analysis. Then there are special matrices are there: diagonal matrix, symmetric matrix, orthogonal matrix, and sparse matrix. Some of the applications in linear algebra in machine learning is, it's mainly useful for linear regression, principal component analysis, neural networks, singular value decomposition, and QR decomposition. Thank you.